Welcome to the deep dive. We basically take a pile of sources, could be articles, research, even your class notes, and pull out the really important stuff, the nuggets of insight. Think of us as your shortcut to getting genuinely informed. We try to throw in some surprising facts, maybe a little humor, keep you hooked. And this deep dive, it's specifically for you. We're tackling Module 101 and Module 102 from that STS 101, Living the IT Era class, Professor Polivares' stuff. Okay, so let's unpack this. We're diving into information technology. What is it? How does it actually work? Where did it even come from? And crucially, why is it like the absolute foundation for pretty much everything you'll be doing, especially if you're heading into fields like nursing or medical technology? It's way more than just computers.
It really is. And what's fascinating when you look at your modules is how IT functions as this engine, really, for modern life. It takes all this raw, messy data and turns it into something valuable, something actionable. It's kind of the silent organizer of our digital world, shaping how we live, how we work, and definitely how we care for people.
Okay, so let's start right at the beginning then, that big question. What exactly is information technology? Feels like a term everyone throws around.
Yeah, it does. And your module gives a pretty solid definition. It basically covers all the technologies we use to create, store, exchange, process, and actually use information. And that information can be, data, voice, video, all sorts of forms. It's this whole integrated system.
Yep.
Hardware, software, networks, managing the data itself, but the core function, the absolute main point, it's transforming that raw data into useful information. That's the fundamental purpose.
Transforming data into useful information. Got it. Sounds simple, but I bet there's a structure to it, right? Like a process.
Exactly. Every complex system needs a blueprint, and in IT, that's the data processing cycle, the DPC.
The DPC, okay.
Your analogy earlier was good, like a recipe or that patient journey from symptoms to diagnosis. It's the sequence IT follows.
So what are the steps in this recipe?
Your module lays out 5 core stages. Understanding these isn't just about memorizing terms. It's like seeing the hidden plumbing behind every app or system you use. So, first up, input. This is all about capturing that raw data, getting it into the system.
Wait, like typing stuff in?
Typing, yes, but also scanning barcodes, using sensors, filling out online forms, maybe even getting data automatically from another system through an API. Think about a nurse carefully entering a patient's temperature and blood pressure into their electronic chart, or a lab tech scanning a blood sample vial.
Right, getting the initial facts down.
Precisely. And the absolute key focus here is accuracy and completeness, right from the start. You often have initial data validation checks built in because, and this is crucial, if the input is garbage, oh, well, you know the saying, everything that comes after is compromised. It's all about reliability from step one.
That garbage in, garbage out thing really resonates, especially in healthcare. You can't afford mistakes there. Are there common slip-ups beyond just typos when inputting data in, say, a busy clinic?
Oh, absolutely. Beyond typos, a huge one is just missing data, an incomplete record. Maybe a field gets skipped in the rush. Another challenge is timeliness. If vitals aren't entered quickly in an emergency situation, decisions get delayed.
Yeah, I can see that.
And just getting different devices, keyboards, scanners, monitors, sensors to all talk to the system and each other smoothly, that integration piece is surprisingly tricky sometimes.
Okay, so we've got clean, hopefully complete input. What's next in the cycle?
Next comes processing. This is where the magic happens, transforming that raw data into something more useful.
Okay, so calculating things.
Calculating, definitely. Like figuring out the right medication dosage based on weight and age data that was input, but also classifying things, maybe sorting patient records by urgency. It also involves sorting data, summarizing it, maybe matching records, updating existing information. This is where the system applies rules, logic, performs operations. It's the computational heavy lifting.
So this is where the thinking happens, digitally speaking.
In a way, yes. And the really important insight here, especially for you going into healthcare, is that the rules and logic used in processing, they're basically encoded decisions.
Encoded decisions, wow.
Yeah. A mistake in calculation, a flaw in how data is classified that can have real consequences for a diagnosis or a treatment plan. This stage is where trust in the IT system is really built or broken.
That puts a lot of weight on getting the processing right.
Yeah.
All right, so we've collected data, input, transformed to processing. Now we need to see it.
Exactly. That leads us to output. The whole point here is presenting that processed information so people or maybe other systems can actually use it.
Like seeing results on a screen?
Precisely. Generating reports, displaying lab results on a monitor for a doctor, creating charts or graphs to visualize trends, sending automated alerts, printing documents. The key focus is making the information usable, relevant, and timely. For patient care, this means the output needs to be clear, digestible, and actionable for doctors and nurses, not just a data dump.
Avoiding information overload, yeah, that's crucial.
Definitely. You want clarity, not confusion, especially when decisions are critical.
And once we have this useful output, we don't just throw it away, presumably, especially in healthcare where you need history.
You got it. That brings us to storage. Its job is to hold on to all that valuable data and information for later use.
So saving files, databases.
Yep. Saving the original input, maybe intermediate results, and definitely the final output. This happens in databases, file systems, and increasingly in the cloud. For healthcare, the prime example is the Electronic Health Record System, the EHR. These are huge digital vaults holding patient histories, test results, everything.
Right. EHRs are everywhere now.
They are. And effective storage means the right information is there when needed for the right person. It supports continuity of care, tracking a patient's health over time. That accessibility and reliability is key.
Okay, input, processing, output, storage. It feels like we're almost there, but the information often needs to go somewhere else, doesn't it?
It does, and that's the final piece, often considered distinct. Distribution and communication.
So sending it out.
Exactly. Transmitting the data or information where it needs to go. This could be securely emailing a specialist report, making patient data accessible across a hospital network, or even having different systems talk to each other directly using APIs, like maybe the lab system automatically sends results to the main patient record system.
So systems integration falls here too.
It does. The main focus is timely, secure delivery only to authorized users or systems. For you, this highlights how crucial that seamless, secure flow of data is. Between departments, maybe even between different hospitals or clinics. It's essential for coordinated, safe care.
Wow, okay. That cycle, input, processing, output, storage, distribution, it sounds complex, but also logical.
Yeah.
Have there been cases where a breakdown in one of these stages caused real problems, maybe in a hospital?
Oh, absolutely. Think back to the early days of trying to get different hospital systems to talk to each other. You might have had a lab system here, a pharmacy system there.
Right, separate silos.
Exactly. If that distribution stage, the communication and integration part, wasn't working well, maybe via faulty APIs, a doctor might prescribe something based on lab results that are hours out of date.
Oof.
Or worse, a patient's allergy information, maybe entered correctly in one system, input, wasn't properly stored or distributed to the pharmacy system. That could lead to a dangerous medication error.
Yeah.
These real-world glitches show why the integrity of the entire DPC is so vital.
That really drives home why understanding this isn't just academic. Okay, so we know the what and the how of the cycle. What about the when? I've heard terms like batch and real-time processing.
Good question. Before we hit batch and real-time, it's worth a quick mention of the types of processing historically. We started with manual data processing. Think accountants with ledgers, all done by hand. Slow, error-prone.
Okay.
Then came mechanical data processing using machines like early calculators, maybe punch card sorters, faster but still limited. But today, it's almost entirely electronic data processing, EDP, using computers, software. It's highly automated, super fast, incredibly accurate compared to the old ways, and handles enormous amounts of data. That's the bedrock of modern IT.
Got it. EDP is the standard now. So within EDP, how does the timing work? Batch versus real time?
Right. So batch processing is where you collect data over a period, say a whole day's worth of transactions, and then you process it all together in one big chunk or batch, usually on a schedule.
Like doing laundry once a week instead of after every item.
Yeah, that's a decent analogy. Think of a hospital processing all patient bills overnight, or a company running payroll once every 2 weeks.
Okay, so it's efficient for big, non-urgent tasks.
Exactly. It's efficient for large volumes, uses resources predictably. The downside, there's a delay. You don't see the results immediately. And sometimes an error in one record can mess up the whole batch.
So not ideal if you need info now,
Yeah.
like in an emergency room situation.
Precisely. That's where online or real-time processing comes in. Here, data gets processed pretty much immediately as it's entered or generated.
Like using an ATM.
Perfect example. You withdraw cash, your balance updates instantly. Or think about booking an airline ticket online. Or in that ER, patient vital signs pop up on the screen the moment the monitor reads them.
Instant feedback.
Right. The big advantage is immediate results, always having the most up-to-date information. The challenge is it requires the system to be constantly available and can be more complex and resource-intensive. And a key type you'll definitely encounter, especially in healthcare systems dealing with patient admissions, orders, or charting, is online transaction processing, or OLTP. Yeah, think of each individual action: admitting a patient, ordering a lab test, charting a medication given as a transaction. OLTP systems are designed to handle a high volume of these individual transactions quickly and concurrently, updating the database in real time.
Ah, okay. So real time is for instant needs. OLTP handles lots of those instant transactions, and batch is for the big scheduled jobs.
Yeah.
That clarifies things a lot.
Exactly, different methods for different needs.